All right, geometry students, we're starting chapter 3. 3 is doing a lot of work with parallel and perpendicular lines and lines that intersect or don't intersect in general, okay? So today we're doing 3.1, identify pairs of lines and angles. A lot of vocab, a lot of this is super important to keep straight. So this is something, again, it's one of those things you don't need to copy my words word for word, because that's not important. It's that you understand the purpose or the meaning behind each word itself, because as they appear in things, you need to know this. So is there going to be a matching section? No, but will these words be important to be able to do a problem? Most definitely, okay? So my first one is parallel lines, coplanar lines that do not intersect. So when we look at those, they are two lines that are here, and I'm going to tell you, if two lines are parallel, they are coplanar. You could have a flat plane that goes between them. So if they're parallel, they're coplanar. You have to have them basically on the same plane to be parallel, okay? You can think of roads that run parallel. You can think of railroad tracks. That's probably the most popular one, that it seems like their rails stay parallel because they're the same distance apart. And of course, these are still lines, right? So they go in the same direction forever. So unlike railroad tracks, they can't turn and twist and such like that. So parallel lines, coplanar lines that never intersect. Skew lines. You can only find skew lines on something that is three-dimensional, okay? So let me start us out with a three-dimensional object. So I'll draw a quick one here. By the way, if you ever have to draw one, you can draw the first box, draw the same shape kind of skewed. So I'm going to kind of come over here. I'm going to actually dot these last ones, okay, because they're hidden. And then I join all these corners like this. This one would be there. So there's my three-dimensional object, okay? So a skew line. My skew lines are two lines that are not on the same plane. So they can't both touch the top of the box, or both on the side, or both on the bottom. They have to be on different parts of the box. They're not on the same plane, and they're never going to intersect. But they're not parallel, because parallel are on the same plane. So it might be this line across here, okay? So that's up a layer. Notice this one down here is down another layer, and it's going another direction. Those two are never going to meet because they're kind of in different layers, okay? If you think about it, we hope our airplanes are flying on a lot of skew lines. You know, if somebody goes up a little bit from the other person and goes in his direction, and then somebody's down a little bit from the last plane and goes in his direction to a different city, they're on those skew lines. They're never going to meet. They're never going to intersect. We hope those airplanes never intersect, right? So, key thing though, they are not coplanar, which means parallel lines cannot work in the skew lines. So if they are going the same direction, they can be parallel and there could be a plane, okay? Quick side note, I'm trying to think if I want to draw this or not. I think I will. So if I look at this back line back here, okay? Oops, not letting me highlight. This back line right back there, okay? That one right there. And then I look at this top one that I made green up here. Are they parallel? And the answer is yes, because if you can think about it, if I could build a ramp between those two, that would be my plane, and yes, they're there. So if they're going the same direction, just even in different layers, then they are going to be parallel, okay? All right, which brings me basically to my parallel planes. Planes that do not intersect, the floor and the ceiling, the east wall, the west wall, those are the entire flat surfaces that do not intersect. Those are parallel planes. Okay, the rest of these go together, okay? And these are going to be super important for the rest of this chapter. So these rest of these, transversal, corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles are all super important. You can write the words, or perhaps a picture makes more sense. Okay, a transversal is a line that intersects two or more coplanar lines at different points. So I have some coplanar lines, okay? They're going through here. And I have a line that comes through and cuts through those, okay? So it makes this, touches here, touches here. This line that's cutting through things is my transversal. Okay, so what I want you to understand, so the transversal is the line that's cutting through there, okay? It hits two lines at once. The transversal now turns those lines or makes angles with those lines. How many different angles did that transversal just create by coming through there? So how many different angles did that transversal create? And I like that answer of 8. So I have 1 here, 2, 3, 4, 5, 6, 7, 8, right? So I have these 8 angles. So anytime a transversal cuts through 2 lines in a plane, it creates 8 angles. And those are going to be really the base of a lot of what we do in the next few sections, is talking about those 8 angles and their relationship, okay? All right, corresponding angles is the first set of angles we want to talk about. So we have two lines in the same plane. We have a transversal cutting through them, so that's my transversal. And I get these corresponding angles. These are angles in the same position from the transversal, okay? So this one's in the top left corner. It matches up with this top left corner on this one, okay? Those are corresponding angles. And obviously I did the top left, I could do the top rights, I could do the bottom lefts, I could do the bottom rights. So if you think about it, there are 4 pairs of corresponding angles, okay? Because we have 4 corners kind of around that where the transversal and the lines meet, and we get those 4 pairs of corresponding angles. All right, next one is the alternate interior angles, okay? So again, I've got some lines in my plane. I've got a transversal cutting through them, okay? Alternate interior angles. So some key words here that we want to make sure we understand. Interior, inside, okay? So think about it when we have these lines from here, they have this inside part. In between the 2 lines is the inside. That's the interior, okay? So my alternate interiors, inside angles on opposite sides and ends of the transversal. So if I choose this angle here, it's opposite, so I flip on the other side and I go to the other end. Here's my alternate interior down here. How many pairs of alternate interior angles can I have? Just 2, because there's only 4 angles inside, so I have to be just 2 pairs of alternate interior angles. All right, next one, alternate exterior angles, okay? Again, we see almost the same words, so when we're dealing with these, right? So I have 2 lines in my plane again. I have the transversal coming through. And this time I see this word alternate exterior angle. So exterior means I've got to stay outside there, right? So I'm outside here. Those are the angles I'm talking about, outside the 2 lines basically, okay? So my alternate exteriors, if I have one on the top left, I have to choose one on the top, or on the bottom right, right? It jumps across the line and on opposite ends, okay? There's my alternate exterior angles. How many pairs of those can I have? Just 2, because I only have 4 angles on the outside. So I only have 2 pairs of alternate exterior angles. All right, last and final one here, we call them consecutive interior angles. And notice there's this also called the same side, okay? So I have my 2 lines in my plane. Transversal cuts through. And I want to be consecutive interior. So once again, I see this word interior, so I'm staying in between these lines right here, okay? And I want consecutive. Now, if you think about it, if you have consecutive wins, they're one right after the other, okay? And or same side, they're on the same side. So if we think about these are inside angles on the same side of the transversal. So if I choose this top one, I have to choose this top one to go with it, okay? So they're either both on the same side of the transversal. Those are the consecutive ones, one right after the other, okay? I will tell you if I ever ask you on a test or quiz what kind of angles they are, if you tell me consecutive interiors or if you tell me same side interiors, I'll give you credit for either one. I will accept either vocab word for that, okay? All right, how are we feeling on these? This is the key of this entire lesson, basically, are these vocab words. All right, so let's turn the page and let's practice some of this. Okay, number 1, I think I fixed everybody's notes, but make sure that you see this G and H that I have here in red. Make sure that you can see those in your notes right there. I think I fixed everybody's, but just in case I didn't, make sure you write G and H back there, okay? All right, so we are looking at a 3-dimensional object right here, okay? And if you were in class, I would definitely try to hold up one of these models so you could see it. It looks like it has a 5-sided figure on the front, and of course that same 5-sided figure on the back. And then we have all these sides that match up, okay? okay? So a couple things as you look at this, okay? I'll erase my lines because it gets confusing. I have a pentagon on the front and a pentagon on the back, okay? Those bases, one on each end. And then if you look at it carefully, again, in a three-dimensional object, it's sometimes hard to see, but all these shapes that are joining them from front to back, I can't even trace it well, these are rectangles, okay? So they're rectangles on each side holding it, okay? Something really simple to think about, if you have, and again, it's easy because they're all rectangles, but if you take like a tissue box, right, you have ends, and then every side that joins those ends of the tissue box are rectangles. And that's true on most of these prisms we're going to see in geometry. So that's kind of a visual or thinking about what we see. All right, so we are going to find all the lines parallel to AF. So here's AF. I want all the lines in this picture that are parallel to AF, okay? And I know I'm not reading all of it. I'm coming back to the rest. So AF is parallel to BG right here. And I'm going to be honest, they call them lines. I'm going to call them segments because obviously they could go on forever, but we're only looking at a part of them. I don't care if you call them lines. I'll take it either way. The next one I see is CH. I see one at DI. And I see one at EJ. Okay, now a couple things here. When I look up there at my picture, all those lines are kind of going in the same direction. So I know that those are parallel. Now, I do want to state this. They are not all parallel to each other at the same time. This is super important to realize. So don't think that because I put them all there, they're all parallel at the same time. But AF is parallel to each one individually. So I could potentially draw or make a plane between AF and each one of those on their own time. You can't do them all together at once. They're not all on the same plane at once, okay? All right. So those are all my parallel segments. And now I want the one that contains the point E, okay? So of all my choices here, the only one that contains the point E is EJ. So EJ would be my answer. Now, this is going to tell me kind of closely to who's paying attention right now to my notes. When you do your homework on this, it gives you similar directions. So make sure you read the homework. So when you go to list them, you could make the long list of everything parallel, everything perpendicular, everything like that, okay? But when it comes down to it, you only need to really give the answer of the one that goes through point B. So all of your answers should have the B in it, but you can list them all, but it's only for your own sake, okay? All right, number B. Let's go to letter B, okay? On letter B, I'm looking for lines skewed to AF. I'm going to stop right there and give everything that's skewed to AF. Okay, let's erase so we can make our new lines. So here's AF. Okay, remember skew says on a different plane, and not going in the same directions would never intersect. So if they were lines that went on and on forever on each end, they'll never touch, okay? So I need a line that's going in a completely different direction and not on the same plane. So looks like I could choose like maybe JI back here. On the other side, this one GH back here. Another one, how about HI? Totally different direction, not going to hit that at all. Not on the same plane. All these side pieces that I use for parallel, I obviously can't use that. So now I'm going to come to the front. I think BC would never touch that. I think CD would never touch it. And ED would never touch it. So I get this long list of all these skew to AF. So not on the same plane, not going in the same direction, never going to touch it if it keeps continuing, okay? So again, as I finished out, which one contains point E? Just this last one, so that's my final answer. So I'm going to write ED as my one skew line that goes through point E. All right, next one. We're looking for lines perpendicular to AF, okay, perpendicular to AF, and containing point E. Okay, but again, we're going to just start at the beginning. What are the lines that are perpendicular to AF? Okay, this is where it's important to remember what I told you to start with, that all those sides are rectangles, okay? So this is a rectangle up here, right? I did not get that where I wanted it. Okay. So I have this. So this right here is a side of a rectangle. So right there, those are perpendicular, okay? So AE is perpendicular to AF. This one over here, FJ, is perpendicular, okay? Harder to see on the back side, but AB would be perpendicular, and FG would be perpendicular. Now, when I finish the question out, it says contains point E, so there's only one answer that contains point E, so my answer would be AE. And again, on your homework, if you don't have to make the list, go short and just go right to the one that contains the point they wanted it to contain. All right, last one here. It says name planes parallel to plane FGH. Okay, so let's first figure out where is plane FGH. Thought I changed colors here. Okay, so FGH is back here. So this is the plane that contains all those points. Where is the plane that is parallel to it? Going in the same direction, never ever going to touch it. Well, it looks like it's this one up here. Remember, when we name a plane, 3 letters, does not matter what 3 letters, does not matter the order of those 3 letters, as long as they're not all in the same line. And when I look at that pentagon, I can't find 3 points on the same line, so I can use any of them. So we could name it plane, I don't know, how about bed, right? BED, that's 3 points off of there. So your choice, what 3, doesn't matter what order, just take 3 not on the same line to name that plane. All right, first time through, feeling okay on this 3-dimensional object. All right, let's move it. We're going to try it again. This time we're going to be short and sweet. We're going to go straight to the answer, okay, instead of leaving all. So on this particular prism, we see MN back here. We want something parallel to MN that goes through the point J. I'd agree with you right there, JL. All right. And the next one, we'll erase that one. Skew to MN and contains the point J. So skew, I can't go in the same direction. I can't ever intersect, right, on a different plane. So I think I'm going to take this JK right here. All right. The next one, perpendicular to MN, so that same MN and contains the point J. So here's J, and I want to go perpendicular. So if I just follow it straight over, there's my 90 degrees. So I get JN. Quick question. Can anything be shared on the parallel, skew, and perpendicular? No. Those words mean completely different things, which means not your answer can't be the same thing for all 3 of those if it's all about the same line MN. Okay. Last one here. Name a plane that contains point J and appears to be parallel to MNO. So here's MNO, this one right here. And I want something parallel to it with J, so it looks like I'm right here. So plane, always write the word plane, JKL. No good words to spell with those 3 letters. All right, 3-dimensional, your parallel, your skew, and your perpendicular, okay? All right, page 3. We have 2 postulates here, the parallel postulate and the perpendicular postulate. It says if there is a line and a point not on the line, how many different lines can I draw through that point that are parallel to that other line? And the answer is 1. There's only 1 line I can draw here that will be parallel, okay? Exactly 1 line and only 1 line. My second postulate, the perpendicular postulate, said if there is a line and a point not on the line, there is how many lines that I can draw through that point perpendicular to the line. So when I draw that there, can I draw any more that are perpendicular? Nope, there's only 1. So it's just reminding us that there can only be 1 line parallel through a point and perpendicular through a point to a certain line, okay? You can't have multiple. All right, and I'm going to be honest, probably we didn't have to have a postulate to tell us that. We probably could have figured it out. All right, in this picture, name a pair of parallel lines. Okay, super, super important that we realize this. Over here, I see these little arrows, right there and right there. That is the symbol, okay, for perpendicular. I'm sorry. Wow. That is the symbol for parallel. Hopefully you'd listen to this one and not the other one. Let me go over that again. That is the symbol for parallel, okay? And remember, we can do the symbol, I don't even know if we did this yet, did we? That the symbol for parallel are those two lines that run parallel, basically. They're often, just so you know, they're usually longer than an L, and you usually slant them just slightly, that symbol for parallel, okay? So if two lines are parallel, they must be marked with those arrows, or you would, they need to be told to you given some way, okay? Just a quick note. Let's say we have a, it's going to be a parallelogram. Terrible picture, but anyways, go with me on this one. If these two sides are parallel, they might give me arrows going that way. But if these two sides on the side are also parallel, they'll change it and give me like two arrows. It's kind of like congruent marks. That if there's multiple things in the picture that are parallel in different directions, they just keep adding more of those arrows. Now, this is what's super, super important to understand. Parallel does not mean congruent. Lines are parallel, it's just a directional thing. So don't think they're congruent because we see these little arrows. Those arrows are not congruent marks, they are simply parallel marks, okay? So I just really want to stress that. Those symbols mean parallel, but they do not mean congruent at any point, okay? So don't assume that those are parallel or congruent. Okay. Excuse me. So first thing first, it says, in this diagram, name a pair of parallel lines. So I want two lines going in the same direction, okay? Yeah, that looks good. AB right there, 2 points. I name a line with 2 points, only 2 points. I put the arrows above it, right? And my second one looks like CD right there. Okay, so I'm going to put the actual little parallel line there, and that's easier to write it that way instead of writing out AB is parallel to CD. Just put those symbols between them, AB parallel to CD. All right, B says name a pair of perpendicular lines, okay? So I'm looking in the same direction, I'm looking for perpendicular. Once again, if they don't give us that right angle symbol, we cannot assume anything is perpendicular. So I'm looking for that symbol right there. So it looks like AB and AC are perpendicular. So AB, arrows on both ends, perpendicular symbol, that upside down T, AC. And remember, I can always write my names of my lines flip-flopped, so I could call it CA if I wanted, that's fine. 2 letters only to name a line. Okay, the last question says, is AB, this line right here, perpendicular to BC, this line right here? Okay, you can probably easily look at that and you say, no, that's obvious, that's a no, right? Here's the reason though, and this is what I want to state to you. So no, it's not. AB is not perpendicular to BC. And we have to remember this. So C was already perpendicular up here at A. So C cannot be perpendicular at another point, okay? So what's important to remember is that we just did that. If C is perpendicular at one point, it can't be perpendicular to another. So postulate there's exactly one line perpendicular to line AB through point C, okay? And again, you can look at it and go, well, that's obvious, okay? But that's kind of stating that postulate from the top of the page. All right, we're ready for page 4. Okay, page 4 is simply another review of those vocab words that we did in our vocab, okay? So again, location, 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 it's all about that vocab word with where these angles are located. So the first one here, 2 angles are corresponding angles. Trying to fit in this little space, corresponding angles. Didn't do a good job of it either. If they are in corresponding positions, okay? So in this case, look at this, top right on that corner, top right on this corner, okay? So in the same positions, that's corresponding. Remember, there's 4 pairs. Okay, so we could give 4 pairs. If I ask you on your homework, and there is a question on your homework for corresponding angles, you should give 4 pairs, okay? The next one, 2 angles are blank angles if they lie between the 2 lines on opposite sides of the transversal. So inside here on opposite sides, we call those alternate, that's the opposite sides, interior, because they're inside. And again, there's 2 pairs of these. Okay, All right, next one. Two angles are, if we look at these, they're outside on opposite ends. So we call these alternate exterior angles. If they lie outside the two lines and on opposite sides of the transversal. Okay, so they're alternate exteriors outside on opposite sides. Okay. And the last oops, let me add that. There's two pairs again on that, right? Okay, and finally, the last one we have for vocab, two angles, if these are inside on the same side, right? These are consecutive interiors. Interiors because they're inside. Consecutive because they're one right after the other, okay? And just so you know, this little box here, the arrow should actually go here. And it says another name for consecutive interior angles is same side. Interior. We still use the word interior to remind us they stay inside. And just so you know, there is no such thing as consecutive exterior angles. So the only ones we do are consecutive interior, okay? All right, so let's practice these, just identifying them here, okay? So on this diagram, let's just kind of make sure we understand the diagram first. So here's my two lines in my plane, okay? Then in between here, this one coming through and cutting through, this right here is my transversal. Let me just give myself space to write the whole thing so you can see it, okay? This right here is my transversal. Okay, that's the one cutting through. Now, I'm going to be honest, any one of those other lines could have been a transversal, but because they numbered these angles with this one, this is the transversal. So any line that cuts through and touches two lines in a plane is a transversal. Okay, so we're going to go through one at a time. First thing we're looking for is corresponding angles. Okay, I'm going to label it over here so you remember that's what we're talking about. Corresponding, there are four pairs. Same position. So angle 1 right here is in the top left. What angle on the right side is in the top left? Correct, angle 3 there. And now you can't even read it. Angle 2 is on the top right. What's on the top right on the other side? Angle 4. Angle 5 is on the bottom left. So what's on the bottom left on the right side? Angle 7. And finally, angle 6 down here is on the left side. What goes on the bottom left on the other one is 8, okay? And a quick reminder, we could have numbered those angles any way we wanted. So don't always say, well, I need to keep odds together, I need to keep evens together, whatever. This is just a random way of numbering these angles, and that's what went together. The important thing is position, position, position. Top left, bottom right, whatever we need to go there, okay? That's corresponding. All right, so my next one is alternate interiors, okay? I'm looking for alternate interior angles. So in my alternate interiors, and I'm going to do a little erasing so I can actually see my picture. Okay, alternate interiors. Inside on opposite sides and ends of the transversal. So if I start here with angle 2, what is on the opposite side and on the other side? So I jump across my transversal, go to the other side, and I get 2 with 7. I only have one other pair of alternate interiors, right? So it looks like what's left is angle 6 down here with angle 3 up here, okay? And again, position, position, position when we are finding these, okay? All right, next one. Alternate exterior angles, okay? Alternate exterior, so exterior tells us outside, alternate tells us opposite sides and ends. So angle 5 is down here bottom left, so we go outside and go top right, okay? So angle 5 with angle 4. And that leaves me one other pair because there's only 2 pairs. And I get angle 1 with angle 8. All right, last and final is going to be my consecutive interiors. Okay, so interior is inside, consecutive interiors, and consecutive means stay together on the same side, right? angle 2 with angle 3. They're both up there on the top. That leaves me one pair on the bottom, angle 6 with angle 7. Okay? So vocab is super important. You want to get used to these. You want to know where all of this is, okay? All right. And we have questions as easy as checkpoint 6 and 7 sometimes. And I will give you something as this easy on a test and quiz, but you need to know the vocab. So on number 6, I have angle 3 and angle 4 here. What would I call those type of angles? So look at their position. Where are they located? Both of them are inside. That gives me a hint that I'm using the word interior. And it looks like they're on the same side, so we call those consecutive. Okay, you can also call them same side, and I would accept that answer. All right, last and final example here in our notes, angle 1 here and angle 2. They look like they're on the outside, so those would be exterior. And they jump across, and they are alternate exteriors. Whoa. All right, so we have alternate exteriors. Now, I'm going to be honest, if other angles are marked, and I'm going to just draw you a quick, like, what if they said something like this, and they said this angle and this angle? Well, they just don't have a relationship. We don't have a vocab word for that. They don't have a relationship. We're not worried about that, okay? So obviously, other angles can go together, but it doesn't mean that they match any of our vocab, okay? So just keep that in mind, that it doesn't matter. There's other relationships, but they're not the ones we're looking at. We're only looking at corresponding alternate interior, alternate exterior, and consecutive interiors. Okay? All right. In your book, page 153 through 28 all, and definitely those are the problems I want you to do. I know we had a little confusion the other week, but those are the ones I want you to do. Good luck. Let me know if you have any questions.